start off, we want to look at what drought impacts you've noticed this year on the landscape where you live or where you work, where you're at. And if you can type that into the chat box, but don't hit enter until we tell you to do that. And then we'll see if we have any trends on that and any notice any recurring themes.
Just had a couple people join, Laura. You might want to repeat.
All right. For any who might have not caught the first, because we did just go right in so that we can make use of every minute, this question that's posted on the screen, what drought impacts have you noticed this year on the landscape where you live or work? Just type that into the chat bar and then, but don't hit enter for just a minute while we're getting everyone's comments. All right, if you can go ahead and hit enter on your comments, and I will stop sharing this so that I can see the chat better. Getting a lot of comments in here. No moisture, agricultural impacts, extreme drought, lack of vegetation, dry, low river, lack of forage, dry again, low snowpack, the vegetation impact again. And so we're seeing some of these comments that repeat, which is not unexpected. Increased fire, that's one that has been an impact this year. The river levels, fire again, is lasted longer, not just the intensity, but the length of it. And low flows, the impact to fish. So these are some of the impacts that we're seeing around because of the conditions that we're experiencing right now. Our first presentation is from Andrea Baer with National Weather Service, and she'll be talking about the current conditions and also the outlook for this winter, what they're anticipating might happen. So Andrea.
Yes, and I am going to need someone to run my slides. Katie was going to do that for me.
Apologies, I've just been admitting people. It'll take a second here just to bring up the slides.
Sorry, I'm not able to do it from my device because of Zoom. Our agency has made it a little challenging to use Zoom, so.
Okay, so I'm going to share my second screen and
perfect.
Move the breakout rooms out of the way. I'm multitasking. So
okay,
and I'll get started with the slideshow from the beginning. Thanks everyone for your patience.
Thank you so much, Katie. Okay, and you'll move my slides along for me.
Yes, if you give me next slide, I will do that.
Yes, okay. So I have a lot of information to pack in 10 minutes, so here I go. My name is Andrea Baer, and I'm with National Weather Service. I'm at the Western Region headquarters, which is in downtown Salt Lake City. And I'm going to talk to you a little bit about the current conditions and what we're expecting this winter. So next slide, please. So look back at where we've been. This is a 3-month evaporative demand drought index, or what we call EDDI, and it's looking at how much soil moisture has been lost to the atmosphere. So they've made it really nice. The color scale down below corresponds with the color scale for the drought monitor, so it's a little more familiar to people. It's taking into account temperature, humidity, wind speed, and solar radiation or cloudiness. And as you can see, the whole southern portion of the western United States has had quite high evaporative demand for the past 3 months and actually through the summer too. It's looked like this for a long time. So dry, dry, dry. Next slide, please. Okay, so looking back at where we've ranked in the state, looking back at summer on the left, which is June, July, and August, the top graphic is temperature. And as you can see, we were very warm through the summer, with the temperatures being in the top 35 or top 10% of above normal temperatures, and then a few pockets of record warmth down in southern Utah. And then precipitation below that shows a very dry western side of our state. And then again, you can see those orange areas, which are showing the bottom bottom amounts of precipitation, the 10% of the bottom category. And a lot of that with the precipitation, we really had a lack of monsoon moisture, that nice moisture that we expect to come up from Mexico during the midsummer into early fall, and that did not materialize at all this summer. So we didn't get the nice cloud cover. We didn't get the humidity, but some people will probably be happy about that. But humidity is nice for the vegetation, and we didn't get those thunderstorms that bring us the rain that we need. So that was a very dismal monsoon that we had this summer, and we did suffer for that. As we move into fall, with the two graphics on the right, the top again is temperature. And as you can see, things stayed warm through the fall for the most part for much of the state, with some record warmest temperatures again down in southern Utah. And as we moved into fall, still very dry, even drier conditions in the fall, with a lot more of the state joining that 10% of below normal rankings for precipitation, and then record warmest moving up into the central portion of the state. So the big message here, summer warm and dry and fall warm and dry, which is not good and has led us to where we're at right now, or a good reason for where we're at right now. So next slide, please. So as we move into what's coming for us this fall, I want to explain a little bit about La Nina. La Nina is a condition in the Pacific Ocean, and it drives a lot of our storm track, especially during the winter months. And as you can see from that bottom graphic, that nice cold pool tongue, that blue area that runs right along the equator up to and a little bit past the date line there, that's what the area we're talking about. And believe it or not, that has a lot to do with our storm track in the United States. So if you look at the graphic on the right-hand side, upper right-hand side there, that's a typical, what we expect when La Nina is in place. That's a typical pattern. And the jet stream shifted a bit north and a bit more variable, but the northern portion of the West and into the Midwest, they benefit a little bit more. The Pacific Northwest tends to get a little more precipitation, and those cooler temperatures stay up further north. And then as you move into the Southwest, you get drier conditions. And as you can see, a little bit of southern Utah is typically impacted with drier conditions during La Nina. So we'll discuss this a little bit more as we move through here. Next slide, please. Okay, this is a busy slide, but stay with me because it has a lot of really great information. And the main point I want to drive home about La Nina is within this slide here. On your left are temperatures, and it's looking back at the years where we've had La Nina in place and what that has manifested itself to be, or what came out, or what was observed in the United States during various La Nina years. So the left is temperature and the right is precipitation. And as you're looking at that, you're looking at the differences from the average temperature. So those colder or blue temperatures, that's where you tend to get, or you had colder temperatures, and the reds are the warmer temperatures if we're staying on the temperature side there. And what I want you to notice, oops, let's see. Thank you. What I want you to notice is how different everything is. I showed you those tendencies or the typical behavior we expect during La Nina on the previous slide. But what I want you to get out of this is it really is variable. No two La Ninas are ever alike. So we can't really say, I'll have people ask me during El Nino or La Nina, oh, does this mean we're going to have this great ski season? Well, they're thinking back to a year when we did have a great ski season during El Nino or La Nina, but that doesn't always happen. And especially in Utah, notice you don't see, if you can squint your eyes there, notice you don't see a lot of those darker colors in Utah. We really do not have a good relationship between, especially on the precipitation side, between La Nina and what manifests in our precipitation. Also in this graphic, if hopefully you can see these slides afterwards, but it starts out with all of the strong La Nina events that we've had before and goes into the moderate and then to the weak. But notice that Utah just doesn't get that real strong signal there. So that's the point I really want to drive home to you. You can't use this as a forecast. This just gives you your range of possibilities for what we have had and what we can expect during La Ninas. So next slide, please. And then I singled out snowfall here. This is a little bit of an older graphic, but it's still fine to use. But as you can see, similar to what I just showed you in that last busy graphic, the northern portion of the West tends to get more above normal or above average seasonal snowfall, and Utah in the northern part tends to dip into that. But it's drier in the south with the exception of those southern Utah mountains. So this is just, again, a tendency. It's not necessarily what we're going to get. It just shows you what's possible or what's typical during a La Nina. And next slide, please. Whoops, there we go. Thank you. Okay, so this is looking at the 3-month outlook or the winter outlook, and this covers December, January, and February. The first graphic there on the right shows you the temperatures and the temperature forecast. You can see that green bubble there. I just picked a spot in the middle portion of our state. And you can also look at the pie chart over there next to it, and you can see that the odds are slightly tilted in favor for warmer temperatures through that December, January, February season. And really, we do have a chance for it to be below normal too, or near normal, but the odds are tilted more in favor of a warmer time during this season. But as you move into precipitation, which is the graphic on the left, for the northern, 2/3 of the state, really, we can't tell you much about what's going to happen there. There's just nothing in our tools that's giving the forecaster enough confidence to make designation one way or the other. So not a lot of information there, but I'll show you some other places that you can get some more information during this time. But then as you notice about the last third or southern third of the state, we do have a possibility or a slight shift in odds for below normal temperatures. And again, that's picking up on that La Nina signal and what typically happens during a La Nina. I do want to point out that this is not showing you anything to do with how much precipitation we're going to get or the amount of precipitation. The darker the color of the contour is more confidence that the forecaster has that it will be above or below average or normal. So I just want to make that point so it's clear. And next slide, please. And all that to say, unfortunately, drought is expected to persist. This is the latest drought U.S. seasonal drought outlook, and it's valid from November 19th through the end of February. And as you can see, Utah is completely painted brown, which means we are expecting drought to persist, unfortunately, through the winter. Next slide, please. So a couple things, I really hope that you'll keep an eye on the shorter range forecasts. You can do that at the Climate Prediction Center's webpage. And I've highlighted in red where you can get more information in the shorter range, since we don't have a lot of information to pass on to you about precipitation this winter. These are some other options, and you can look at the 6 to 10 day outlook. I've highlighted down here the 8 to 14 day outlook. So that's valid from December 10th through the 16th, and it tells you that our forecasters, the odds are favoring cooler than normal temperatures, especially for the northern part of the state. And then unfortunately, still slightly favoring dry or below normal precipitation for the entire state as well for that second week there. You can also get the same type of graphics for weeks 3 and 4 to look a little further out. And then over there on the left, you can see that I have 8 to 14 day US hazards highlighted. And that's an outlook that comes out every day. And only things that are painted on that map are areas where the forecaster has some respectable confidence. So you can look at that each day if you wanted, and it tells you during the 2-week period where you're going to have a high risk of temperatures being above or below normal, precipitation, etc. We also have wind and snow there as well. And that's something to keep an eye on. And again, keep in mind that that shows you when the forecaster has confidence in those things, he or she is going to paint that on that map when you look in there. So I highly recommend using that in the shorter time frame. And the next slide. Okay, so to summarize, doing all this in 10 minutes is a challenge, but we had a warm and dry fall, and that followed a very hot and dry summer. So that brings us to where we're at, and part of the good reason we're having this meeting today. La Nina conditions are in place in the Pacific Ocean. We're currently having a moderate strength event, but the forecast does have a possibility of that becoming strong, which just means we might see more impacts or greater impacts. For the majority of Utah, though, there's really no statistically significant relationship between La Nina and precipitation. The exception for that, as I showed you before, is far southwestern Utah, where they're typically below normal precipitation. That's typically what we expect. The winter outlook slightly favors above normal temperatures for much of our state and below normal temperatures for that southern Utah area, but no clear signal for the northern half, and we'll need to use some other types of information to get that in the shorter time range. And then drought conditions are expected to persist this winter. That is the outlook. Again, keep an eye on those shorter range forecasts of the website I gave you before. Also for the next 7 days, turn to our 2 local forecast offices that cover Utah, which the first one is in Salt Lake City, and that covers most of the state, but then also WFO Grand Junction in Colorado covers the eastern portion of our state. And I would also recommend looking up the Colorado Basin River Forecast Center, which you can find in that website right there as well. And they will have all kinds of information on water supply as we move through this winter, and more importantly into next spring, and stream flow, and all kinds of great information through the various portions of the Colorado River Basin. So keep an eye on those 3 websites for more localized information. And then my last slide, I think, is just to thank you all. And if you have any questions, you're always welcome to email me. If I can't answer it, I can always contact one of our local offices, and they can give you some better information. So thank you very much. And let's start hoping for rain, lots of it, and snow.
Thanks, Andrea. Hi, this is Emily. I'm joining the call now. And there's a question in the chat box. Can you put those websites into the chat, please?
Oh, yes, I will do that. Well, yes, I will put those websites into the chat.
Great, thank you. And I see we're a few minutes behind time, so I'll go ahead and we'll have some time later on for some more direct interaction and questions. So I'll go on and move to Brian Fuchs with the National Drought Mitigation Center. He is going to talk about the U.S. Drought Monitor, and he is a Drought Monitor author. So it's great to have him here, one of not very many across the nation. So it's great to have Brian here to share with us about the U.S. Drought Monitor.
All right, thanks, Emily. Can everyone hear me okay?
Yes.
Okay, I will share my screen and pull up my PowerPoint. So can everyone see my slides okay? I'm assuming so. So as Emily said, my name is Brian Fuchs. I'm with the National Drought Mitigation Center, and I am one of the U.S. Drought Monitor authors. And over the next 15 minutes, I am going to talk to you about what the Drought Monitor process is, how the map is made, and how people can contribute to this process. I know it's starting to get ramped up in Utah right now, and I've talked with several of you about this process, but really just some ideas of what the process looks like, what it is and is not. And this is really an abbreviated version of a longer talk that I typically give. So there's going to be some things I go over quite quickly. So from the beginning, scientists have been trying to identify drought areas for quite a long time. This is a picture of a map from 1934 that came out from USDA, and they were trying to see how crops were across the country during the Dust Bowl. And you can see by this map, they had broad designations of where things were going good and not so good. And this was just an attempt of showing drought conditions across the country. So the Drought Monitor came about in 1999, and realistically, there were some early efforts to look at drought. So on the left-hand side, everyone's probably heard about the Palmer Drought Index. It's been used for quite some time. And one of the major drawbacks of the Palmer was it was developed in the Midwest and was developed to show Midwest type of climate and conditions, but it's been applied everywhere. And you can see from this is a long-term Palmer from 1999. And then on the right-hand side is an early hybrid approach that was the Drought Monitor in the early days, and trying to take the best attributes of many indices and indicators and put it all into one map was the main goal, and still to this day continues to be the main goal of the Drought Monitor, showing all the different types of drought on one single map. So with the Drought Monitor, the idea is to be objective, and that's the indicators and indices that we look at that identify drought. But we also incorporate the subjective portion, which is the expert tease of many across the country, as well as the inclusion of impacts, what people are seeing on the ground. And those together make up the U.S. Drought Monitor. So this idea of using just that single index approach, such as the Palmer or the SPI or SPEI, we're able to take and use all the attributes of many in this hybrid approach. And I see there's things popping up in the chat, but in my presentation mode, I'm not able to see those. But if there's a question, please put it in the chat and I will answer it when I'm through with the presentation. So this is what the Drought Monitor looks like. This is an older map from a couple of years ago, which is kind of indicative as we're still talking about drought in some of these same areas. And this is from the fall of 2018. And not only have we seen drought get worse in that 2-year period, but it's also expanded. On this map, you see a series of S's and L's, which talk about short and long-term impacts, and also a combination of S and L, which is both short and long-term impacts being experienced. And when we go into the Drought Monitor, the idea is we're showing all types of droughts. We have meteorological, agricultural, hydrological, socioeconomic, as well as ecological drought, all on one map. And the idea behind that is the decision makers and the powers that be back in the early days of the Drought Monitor said, we don't want to see multiple maps. We want to see one map that has all this information on it, and we don't want to have to go through several different products. So that's why on the Drought Monitor, all these different types of drought are being shown on a single product. And we do use those labels to try to discern between the different types of drought. So this is a three-way partnership between the NDMC, where I'm at, NOAA, and USDA. And it's been that way from the beginning. A typical drought year will get 12 to 13 million hits on the website, and a substantial drought year like this year, that pushes more than 20 million hits. And we all know that it's been used in different USDA products, as well as the IRS, as well as many other programs. So the backbone of the Drought Monitor are the 5 intensity levels. D0, or abnormally dry, is not considered drought, but D1 through D4 is considered drought. And I'm going to dig into these a little bit more in another slide. So when we start talking about the drought monitor, a lot of times it's easier to talk about what it is not. And so the drought monitor is a current assessment of drought and current impacts all on one map. It's not a model. So we're not taking a bunch of data each week and plugging it into a black box model and having the map get put out. We're manually looking at all these data in GIS, and the authors, along with the expertise across the country that communicates through an email list server, that's how we are moving those lines each week. The drought monitor is not interpreting only precipitation. That's probably one of the biggest issues that I see coming from the public when they ask me questions, and I get about 1,000 to 1,500 questions a year directly to me related to the drought monitor. Many times we'll get that information. Well, I've seen rain in this area and the map didn't change, or there hasn't been rain in this area. How come the map didn't change? We're looking at precipitation, but also several dozen other inputs as well. So it's not trying to replicate where it did and did not rain. There are many tools out there that do that already. The drought monitor is not a forecast or a drought declaration. Again, there are products that are using the drought monitor looking forward, and Andrea showed the seasonal drought outlook is one of them. And a drought declaration can only come from a state's governor. So they may utilize the drought monitor in making that decision, but it is not an official drought declaration just because the map is showing drought in an area. The drought monitor does not take into account any relief programs when we're doing the map. So the idea is the relief programs that are utilizing the drought monitor are doing so knowing that it's an unbiased product that is not taking into account who is and who is not getting relief based on the drought monitor when the map's being made. I already talked about the short and long-term impacts, and the time frame associated with short-term is typically 6 months or less. Longer term is typically 6 months or more. We just had a workshop this week talking about flash drought and seeing if there could be a different label on the map showing flash drought conditions that would be on the scale of a couple weeks to maybe 2 months. We do incorporate local expert input. Typically, they're talking about impacts that are being observed in their area, as well as validating those physical indicators that we do look at. So if a drought index is showing one thing, but the conditions on the ground are showing another, that's what those local experts can really relay to the drought monitor authors. They know their backyard better than anyone and know when things are better or worse than they should be. The authors, we try to be, and we have to be as objective as possible. We don't get a bonus for showing more or less drought on the map, and we use this convergence of evidence approach, which I'm going to touch on in a little bit. The physical data and drought indices and indicators must support the depiction on the map, and impact data validates these physical data, but impacts alone will not drive changes on the map. I think that's a key point to make. So in doing the map, we do use these percentiles. And so every one of the pieces of data that we look at can fall into the D0 through D4 categories using the percentiles. It can be applied to any parameter, and any period of record can utilize this methodology. So just to be on the map, so just to have the yellow shading on the map means the majority of the indicators are falling into that 21st to 30th percentile, which is D0. And then when we start seeing the D3 and D4 on the map, that's saying that the majority of the indicators that we're looking at are falling into that 1st to 5th percentile. And when you get to D4, that's saying that you're typically only seeing conditions like this about once every 50 years or so. So that is indeed exceptional drought, is that rare event. So when we start looking at these timescales of drought over the entire history of the drought monitor, we can see that there has been drought at different scales, at different intensities, and different coverage throughout time. But what is interesting with the drought categories and the historical ranking or likelihood behind them, it takes away that anecdotal or subjective nature. For many of us, we typically think that, oh, the last significant drought that we were in was the worst it's ever been. But when we start looking at that long-term data, that does become anecdotal. And we try to eliminate these comments as like, I don't remember it ever being this dry. We have to be D3, or it's really, really dry. It should be D whatever on the map. When we let the data drive that decision making, That's what makes the strengths of the U.S. Drought Monitor come out. It is data driven. So how is all this done? Well, again, I mentioned the authors. So here's a breakdown of where those authors are. Unfortunately, right now, we only have one author in the Western U.S., and that's Dave Simmerl at the Desert Research Institute in Reno. We do have 3 in Lincoln, Nebraska. We have 1 at NCEI in North Carolina, and the other 5 are located within the Washington, D.C. area within USDA and NOAA CPC. Requirements of an author must work at a regional or national center, government or academia research area, and we are all volunteers. The work that we do comes on top of our other job duties, and even though USDA has supplied a great amount of support over the years to NDMC to keep a lot of the operational things going with the Drought Monitor, there is no line item budget for the Drought Monitor to be produced. When we start looking at the data that goes into the Drought Monitor, this slide really encompasses all those several dozen pieces of data that we look at. So when we look at these here, again, starting at the 12 o'clock position and going around the dial, drought indices are still a key to the Drought Monitor. And in the last few years, there's many drought indices that are being computed on a regular basis that we can utilize. Soil moisture, both modeled and measured, is a huge piece of data that we look at. And right now, we're fortunate enough that there's been a lot of effort to expand upon this, and more data sets are coming out related to soil moisture. Stream flow, wet reservoirs and wells, again, that hydrological aspect of drought are key, especially when we start looking at water allocations and water availability. Remote sensing's really stepped up in the game over the last decade. I've been a Drought Monitor author for going on 16, 17 years now. And over the years, the remote sense data has really come into play and is being utilized more and more, especially with the high resolution of these data sets. I talked about the expert local input and impacts and also precipitation and snow, especially in Utah. This is going to be key. We're utilizing the SNOTEL data. We're utilizing all that information from the upper elevation locations as well as the valley locations to get a good idea just on what that runoff will be and the availability of water coming into each spring during a typical water year. And again, most of this information analyzed each week falls into one of the categories, and anywhere from 40 to 50 unique indicators are looked at in each week when the Drought Monitor is put together. This slide just touches on the newer satellite products. Across the bottom, we have Veg Dry and Quick Dry, ESI. We've already talked about EDI. And then also on the far bottom right, the GRACE satellite-based information on soil moisture and groundwater levels are also utilized. And again, over the last 10 years, we've seen several of these products get ramped up, and we're able to utilize them all in the Drought Monitor process. So another thing that comes up quite often is someone will ask about drought in the past and how come the map didn't show it one way or another. And once the map is completed and published for the week, the map is final and no changes will be made retroactively. And this is with a weekly product. We hope that if there are issues that were missed one week, they can be picked up on the following week. It's not a practice that we want to get into of going back 6 months prior and trying to adjust a map when the data isn't there anymore or whatnot. So once the map's finalized, it's final and there's no changes that are made. So how do people get feedback into this process? I know I got a couple minutes here, so I'll go through some of this quickly, but we're going to talk about this later on through the program today. So we do have these Drought Monitor forums that have taken place, the regional climate centers, state climatologists, tribal groups, USDA, State Drought Task Force, NIDIS with the RDUs, they all contribute to this feedback process in various forms that get information up to the authors in the Drought Monitor process. So how can people contribute through this? Again, having multiple points of contact responsible for pushing this information up to the author is needed, because if someone's gone or on leave or sick or whatnot, it's good to have that backup. And rotating this responsibility so multiple people are well versed in gathering and consolidating that information for the state or region and pushing it up to the authors with a condensed consensus depiction. Some of these groups have virtual meetings, phone calls, they have their own separate email list servers, they use Dropbox to share data. So a lot of this is being done in a number of ways. And I don't say that one's better than the other, but I want it to work for the group that's trying to do it. Groups will establish thresholds on when they should meet. Some will only say once they meet D1 at any part of their state or region, they'll get together at that point, and they'll meet every week, every 2 weeks, depending on the season and needs of the group. How will the impact information be collected? Will it be utilizing NDMC's tools or COCORA's tools, or is it going to be done at a state or region level? But then how will that information be shared? Ideally, positions or departments would be identified in a planning document so people come and go, these responsibilities will continue. We saw this recently up in Montana, for example. In the past 5 years, they've had 2 or 3 different changes in how this was being done in Montana. And it took some scrambling by the group up there to kind of get reorganized and get going again. So just again, naming groups or departments is usually better than naming people because people do come and go. This is just some stats on the email list server. If you're interested in participating in this weekly production of the Drought Monitor, please contact me. I'm the one who oversees this list server. And we got over 450 people now on that list. And we'd love to have more. Just a PDF of some information on the Drought Monitor that people can use. Many partners that we work with, doesn't even broach everyone that we work with, but just some of them up there. And I'll put my contact information up with my email address. With remote working, it's probably best to get in touch with me by email right now. But if there are any questions, I know I'm right up at my 15 minutes, so we'll probably have you put questions in the chat box and address them there. Thank you.
Great, thank you, Brian. Yes, please, if you have any questions for Brian, feel free to put them in the chat box. We will find a time during this 2-hour session to answer those questions. We will circle back to those. And now we are going to move on to hear about COCORA's, which Brian mentioned very briefly. We're going to hear from John Mayer with the Utah State University. He's the Utah COCORA's coordinator, the regional coordinator for Utah. And COCORA's is, if you don't know, the Community Collaborative Rain, Hail, and Snow Network. And we're really excited to hear about how that sort of citizen science or ground-based science network is progressing in Utah. So over to you, John.
Well, thank you, everybody. Good morning from Utah State University, where the Utah Climate Center is housed. Thank you to all the participants and the organizers. Let me share my screen. I'm assuming everybody can see this. I see some head shaking there, so that's good news.
Yes, it's not in presentation mode yet.
There we go.
Perfect. You're set.
Okay, so I'll spend my 10 to 15 minutes giving a quick rundown of what COCORA's is. Thank you, Katie, for already letting everybody know how to pronounce it, because that's the first challenge in the process. I'm the state coordinator for COCORA's, so I tend to do most of the organizing and working with our volunteers and trying to build the network. So I'm happy to give a presentation here because COCORA's, in my opinion, is one of the best bang for the bucks that we can have for monitoring precipitation patterns, as well as some more recent features that they've implemented in the network to allow us conditional monitoring and soil moisture monitoring, which I'll speak on shortly. So what is COCORA's besides being maybe the worst acronym to try and to give to the community and one of the more annoying acronyms to type out? COCORA's is the Community Collaborative Rain, Hail, and Snow Network, started in 1997 by the Colorado Climate Center following a deadly flash flood event that was not captured by local rain gauges very well. So COCORA's is a network of volunteers. It's similar to a citizen science type of networks, consisting of all ages and backgrounds working together to measure and map precipitation in all of its glorious forms: rain, hail, and snow, and everything in between. Since the network's inception in 1997, over 22,000 observers have partaken, in all 50 states, and the network is now international, expanding to other parts of North America and even beginning to expand into parts of Europe and other places of the world. So it's a very successful network that is proven capable in accomplishing its goals of measuring and mapping precipitation in a fun and easy way. Just this last year, everybody was very excited as we surpassed 50 million observations in the network's history. So woohoo, that's fantastic that these are all coming from local volunteer observers that are just passionate and observing precipitation in their backyard. Utah, we entered the network in 2008 and have since accumulated about 350 observers, although currently active observers this year we're at about 90 to 95. You can see the map here in the lower left corner indicating the location of all of our 2020 active observers. And you can see we are clustered mostly along the northern Wasatch Front where our population densities are greatest, and we have significant gaps throughout the rest of the lower populated areas of the state. So as anything that involves asking people to volunteer their time, especially with citizen science, it takes a pretty significant sales pitch to convince a lot of people to join. So the sales pitch for COCO-RAS is, you have to convince people why they're going to love doing it. It's a hassle-free and commitment-free network. There are no requirements asking daily observations to be submitted at certain times. It's really any observation is a good observation. And people really enjoy the fact that they aren't required to submit observations 7 days a week, 365 days a year. So people that come and go, we have a lot of wintertime citizens that move to the states down in the southern Utah regions. And they oftentimes will report for just a few months of the year, and that's totally fine. We like to say, if you get sick or you go on vacation, we're not going to send the COCO-RAS police after you to collect your observations for those missed times. It's perfectly fine, and people really enjoy that hassle-free and commitment-free atmosphere. It's incredibly inexpensive and unobtrusive. Typical rain gauge kits that include the mounting hardware and everything needed to become a volunteer are usually less than $40 shipped to your house, so it's fairly inexpensive. And it's unobtrusive. Just about everybody can find multiple locations on their property to mount these gauges to pre-existing structures. Or what a lot of us do is we'll create and build a very simplified mounting system with some 2x4s and some 4x4s that allows you to move it around your property and find the most optimal place to take measurements. It's very easy to learn. I'm being honest when I say I have kids less than 10 years old that do this at home without their parents' help. So it's also fun and educational, but anybody can quickly learn and train through the online available training resources to become an observer. They've made it incredibly easy for new volunteers to quickly spin up and feel confident in what they're doing in terms of placing their gauge and taking accurate measurements. And obviously the value to individuals and their community is a wonderful sales pitch. We have a lot of people that enjoy knowing how much precipitation fell on their property, ranging from gardeners all the way out to ranchers and farmers. And the feeling that it gets the reward that you're providing information that your community benefits from the water resources perspective is also a really easy sales pitch. Utah is obviously very data sparse. We have regions of the state that have very little official rain gauge measurements, and so we're forced to do lots of extrapolation. We have also a second part of this is we have a very highly variable precipitation patterns with our complex terrain and our north to south gradient of types of climate regions that we experience. So Utah's COCO-RAS observers provide really a lot of valuable information that one gives us a far more high definition precipitation picture. Think about as we're adding more pixels to the precipitation pictures than what we currently have. Give you an example of what COCO-RAS can do for precipitation patterns. This is one of my favorite examples taken from an Illinois precipitation event showing what a map without COCO-RAS data versus with COCO-RAS data. And you can see across the state the additional COCO-RAS information that's reported from these volunteers using inexpensive rain gauges really amplifies the fidelity of the precipitation picture for this storm event. We capture the local maxima and gradients of precipitation far better. And that's always useful when we're looking at regions of precipitation where highly variable patterns exist. And also, I think one of the most important aspects of Utah's COCORAS observers is it provides a voice in these data sparse rural areas that don't have very many official gauges, if they have any at all. So when I talk about official gauges, I'm talking about the really expensive state or federally funded, calibrated and maintained gauges. And these are sparse because, of course, they're expensive to put out, and it takes somebody going out consistently and maintaining and calibrating these. So COCORAS observers provide a voice to these regions that might not have these more expensive state and federal gauge networks populating many areas in those regions. So COCORAS observers in these data sparse areas, their information is, in my opinion, by far the most valuable component of COCORAS for our state. So I'll give you a rundown of the equipment and just to show you how unobtrusive it is and how inexpensive we can get. This is the typical official rain gauge. It's a 4-inch heavy-duty plastic cylinder. I have dropped these during very cold conditions onto the sidewalk, and they do just fine. Some of the gauges that we have been around for 10 or 15 years, sitting in the sun in the harsh conditions, and they're still totally usable. When you purchase the gauge kit, you also get the removable funnel and inner 1-inch graduated cylinder that keeps what we call the rain mode. So during warm-time season, you can far more easily measure precipitation with that inner cylinder. And then this little stand that you see in this nice photo represents what a lot of people do in their fields or their backyards, as opposed to mounting to the side of a fence or a shed or something like that. So it's fairly easy to mount. It doesn't take a lot of costs or resources to get one of these gauges put up. Some of the more dedicated and passionate observers in the network will also purchase a snow pad and ruler to take snow measurement depths each day. And also hail pads can be made up, which consist of styrofoam wrapped in aluminum foil that preserves the diameter of hail falling on the ground. These hail pads can then be sent into state coordinators or the national coordinators to take and measure and archive the historical hail events that a location can observe. We don't have too much of a hail problem in Utah, but we do have some observers that are hoping to capture some of the infrequent periodic hail that might occur, specifically during the monsoon season. So how does it work? So the simple observations are taken each morning. It can take anywhere from a minute to maybe 5 minutes, depending on if you have a lot of snowfall to melt and observe. But it's incredibly simple. It will not add a lot to observers' daytime routine. I take my little 3-year-old daughter out in the morning and we look at the rain gauge, and it's a fun bonding moment for us, and it's incredibly simple to do that. Observations are reported in an equally simple method. Cell phones have mobile apps and online browser as well. So you can take the observations and submit it on dry days when there's nothing in the gauge. It could take 5 seconds. You don't even have to go outside. On days with rain, it could take 30 seconds. On days with snow, it's a little bit more involved, but it typically won't take more than a few minutes, maybe up to 5 minutes. Those submitted daily observations are immediately mapped and made public facing. It takes just a few minutes for the COCORAS servers to do any quality control and to pass those onto the mapping interface. And so you can see in almost near real time observations coming in across the region and the country to see what kind of precipitation has occurred. And they do have a newly implemented mapping interface. It's a wonderful improvement. It's fabulous. It's fun to play with. Especially for the weather weenies across the state that just like to see precipitation patterns as they're happening. The figure on the right here shows Utah's collection of November total precipitation. One of the nice things about the mapping feature is it will allow you to create custom ranges up to 45 days long. And so you have the ability to look at total precipitation over a longer window than a single day, which is nice for drought monitoring. Some of the benefits and uses, we oftentimes ask, where does our data go? Does it just simply go into a quiet ghost server and nobody ever looks at it again, and it's It's very nice to be able to tell people that observations that are submitted are immediately used by a large spectrum of scientists and hydrologists, and even sometimes broadcast meteorologists. So there's a lot of benefits and uses from these observations. Anyone can immediately and easily access daily observations and historical archived observations. And their website is not complicated. It doesn't take a PhD to go through their mapping interface and figure out how to look at the data. There's a minimal delay in when the observations are available, down to a few minutes. And the mapping tool, it has that really nice custom date range that'll show you total precipitation. Significant number of scientific uses. I'm going to show just a few of them that are more pertinent to the audience today. Obviously, water resource managers can look over in the past and see water resources that have accumulated where we don't have those official rain gauges. Meteorologists and hydrologists will look at these anywhere from a seasonal perspective down to a daily perspective, and sometimes they might even help aid warning coordinating meteorologists in issuing flash flood warnings or that sort of thing. Emergency managers will look at this data again, just trying to understand precipitation patterns. The USDA looking at it from a drought perspective, and I'm sure Brian and his team will look at COCORA's observers as part of their funnel of information. And my most fascinating part with COCORA's information that I think resonates with a lot of people is it can be used for mosquito control. Who doesn't like the thought of destroying mosquito communities across the country? So COCORA's data can really help fine-tune where mosquito control can go. And I really love this picture. This is from our Wyoming network. And Tony out to the state coordinator out in Wyoming, the snapshot of an antelope checking the rain gauge out on the range there, and advising Mark at the drought authors that they can improve the area to a D2 from, I'm assuming, D3. So wonderful picture there. Shows a lot of the benefits and uses in this list. A lot of people are worried that they'll buy a rain gauge and they won't know what they're doing. The training and support that has been made available from the national coordinators is fantastic and really fun to watch. They've really taken a fun approach to the training. They have videos as well as slide presentations that have been put onto their website. So really all ages and all technical experiences can go and learn how to purchase a gauge, where to put it, and all the different nuances of measuring the various different types of precipitation and how to report it. Utah is broken up into a collection of regions, and we have a wonderful collection of coordinators throughout the state that are available over email and sometimes in person, given the right circumstances, to help out any interested members that are new to the community or might have questions as they're going through unique instances of measuring precipitation on any given day. Conditional monitoring is one of the most fantastic things that I think drought monitoring can benefit from in the state. This allows observers to use their local knowledge of climate and weather and support a more qualitative assessment of local conditions. This can be done through mostly a weekly reporting is what we really ask for our observers to produce. So on the weekends, come in and report the conditions that you've experienced over the last week. Again, it's rather qualitative, but allows us to assess trends and general conditions that are based on local knowledge as opposed to data sets. And so this is one of the really valuable parts that I think Utah can benefit in terms of drought monitoring. One of the last things that they've implemented over the last couple of years is this soil moisture monitoring. It's fairly time and labor intensive, so it's certainly not for everybody, but it does provide the opportunity for observers to go and take actual soil moisture measurements. It involves drying soil samples in an oven, so again, it's not for everybody and it's fairly intensive, but it does provide an avenue for this information to trickle into the drought monitoring funnel of coordinators and managers across the region. So I'll wrap up here with just a quick overview of what it takes to be a COCORA's observer. It's fairly easy, 5 simple steps. You can sign up at the website listed. The purchase of the 4-inch plastic rain gauge, they are on sale right now. I think it's $32 is what the entire gauge kit is going for right now. watch the quick training slideshow or attend a training session that we might offer here if we get enough observers signing up. Put the gauge up in a good location and you're off and running. Start observing precipitation and report online daily. So that's what I have. Every drop counts, especially in this state, which is a fantastic motto for the network. Questions can be sent to my email address, or you can sign up directly at cocoras.org. Thank you, guys.
Great. Thank you so much, John. It's really a great effort, and we really appreciate you and all your efforts in making that happen in Utah. In the interest of time, if you have any questions for John, please drop them in the chat box. And now I'm going to introduce Seth Ahrens with the Western Water Assessment. And he's going to tell us about our group discussion, because we really want to hear from you and break up into some smaller groups to have a discussion. Seth.
Great. Thank you, Emily. All right. Is everyone seeing the screen share there of a slide about Utah drought impacts?
Yes. Yeah, you're set.
Great. So I'm just going to give a real brief introduction before we head into our breakout sessions. This breakout session, we're going to now transition a little bit to talking about what the impacts of drought are in Utah. And Brian spoke a bit about what the different classifications of drought are and the kind of information that goes into those drought classifications. But those classifications in and of themselves don't necessarily tell us a lot about what drought looks like on the ground. So as kind of a primer to start this conversation about drought impacts, I wanted to go through a product that's available on drought.gov that you can look by state at what specific drought impacts are for your state based on the category. So I just wanted to go through these briefly before we head into the group discussions. So at D0, which is considered abnormally dry in Utah, we'll see impacts of dryland crops are struggling. Water is limited for cattle. At moderate D1 drought, soil moisture begins to become low. Winter crops may not germinate. Feed for cattle is more limited. Springs may begin to dry. And then with severe D2 drought, we see that some other impacts such as pasture and water are inadequate for cattle. Air quality might be poor. We do have issues with dust pollution, especially during dust storms when there are wind events that can pick up and train dust from dry playas in the western desert or other areas where soil is disturbed in the desert. We may have low snowpack during severe drought, and streams and ponds may begin to dry. During extreme D3 drought, we see increases in fire danger, native vegetation may be stressed, and stream flow is low. And finally, in exceptional drought, there may be more fire restrictions, and this may be a situation where some water providers might have to cut irrigation water allotments. So with that introduction, I think that we will break out into groups, and each facilitator has some questions that they'll be asking, and facilitators will need to remember to take notes or ask someone within the group to take notes for you.
We'll go ahead and keep this at 15 minutes, facilitators, just so you know.
And I'm just pasting the first question, and I'll paste the second question into the chat box. Okay, and breakout groups are beginning now. See you, everybody. Hi, Tice. Do you need to go to a breakout room or are you taking a break?
You can constrict the time slider on either end and also push play if you want to look at reports for just a particular period of time. And it will be, as of next year, or it is currently via this link, mobile friendly. The cool thing, if you download the Survey 123 app onto a relatively recent mobile phone or tablet, I say that because it crashed my older phone. If you download the app, it will, and enable geolocation, it will absolutely pinpoint your location. And that saves us some user error that results from people entering their own user locations. So in order to use the mobile app, you want to install it on your device. Then you can either scan this QR code or use the link below. It'll take you to a page that asks you, do you want to enter a report in the browser or in your field app? Choose field app if that's what you want to do, or you can certainly do it from your browser on your computer. Be sure that geolocation is enabled. Download the survey. It will prompt you the first time you do it to download the survey. Then you can take photos right there on your phone or your device and fill out the form. And then you can choose to upload it immediately, or you can wait until you're back at your home or office or someplace with a better Wi-Fi connection. So the app is, I think it works pretty smoothly, and I'm particularly interested in the precise geolocation that it offers. If you prefer not to provide a precise geolocation, you can type in a nearby place, such as a city or a county, and then it will be mapped to that city or to the county centroid. And we also have a step that you can see down at the bottom to select your state or territory and then select your local jurisdiction. That helps us with quality control, because if people select their point on the map and then scroll, it does kind of move the marker around in unexpected ways. So we get things from Missouri that are showing up in Arkansas or in the Pacific Ocean, that kind of thing. So this quality control step is helpful. I'm hoping the mobile app will help us get around that, the need for that a little bit. So I already mentioned the time sensitive capability of the map. That's pretty helpful. We ask observers to rate conditions on a 7-point dry to wet scale. This is the same scale that COCORAS uses for its condition monitoring reports that was originally devised in the Carolinas. So there's quite a bit of citizen science experiential wisdom going into this scale. And it also provides a common layer to CMOR reports and COCORAS reports, and in some cases, a few states that are doing their own Survey 123 reports have also adopted this question. And so that's a nice common layer across different report collection sources. We have a question about experience. I didn't map it very well in 2020. For 2021, the intent of this experience question is to put people's context and experience of in the drought monitor context. Is this a 1 in 50 year observation? Obviously, not a lot of people are going to be able to tell us that, but is it a 1 in 20 year, a 1 in 10 year experience? That's what we're trying to get at with this question. Then the bulk of the report form is this impact checklist. People can click on the wedge, the right pointing triangle to the right of a sector to expand it, to see detail on that. When you do that, you get a lot of individual impacts for that sector. And down at the bottom is the other option that opens a free text box, and you can fill in what you might be experiencing. Then we, in addition to putting it all on one map, the overview layer, we create layers for different sectors. And this was at the request of some people who were using the map. And if you click through to these specific sector maps, a few of them, we've pulled out specific impacts that various folks have indicated were of special interest, like reduced yield for crops, livestock, reduced pasture conditions. Next year, we'll also have reduced surface water for livestock and dry wells. These are all specific impacts from those lists that people wanted to be able to see more easily. People can upload photos. These are a couple that were uploaded earlier this year. We have some language asking people for detail about the photo, and also kind of a photo release form saying that if you're uploading it, you're saying we can use it. And then we ask people to provide information that allows us to put this in context. What should things be looking like this time of year, or what is a more typical experience? New for the survey that we'll be launching at the beginning of 2021 will be an observer type question. We'll be asking people to tell us whether they're extension, producer, water supplier, homeowner, climate or weather professional. We may come up with a couple of additional items. And we'll also ask people to specify what privacy level they would like to have, whether it's okay to publish their name. Some people actually do say, publish my name with this report. And that may be most appropriate if you're, for example, an extension agent reporting on behalf of a county, or somebody, at a very prominent local ranch or something like that. Another option would be that people could share their contact information with state climatologists, drought monitor authors, but not with the public as a whole. And then finally, not to share any identifying details at all. That has come up because there are, if people are just reporting anonymously, there's a question about how seriously to take them. There's kind of a credibility issue. So having some degree of a little different ways of identifying yourselves might help. This is what it looks like if you drill into a point for detail. A photo will show up as an attachment, although I believe there's a way in the maps we'll be implementing next year that you'll see thumbnail photos in the pop-up boxes. So when you click on a point, you get this pop-up box. Hopefully you'll see a photo thumbnail at the bottom of it, if it exists. Then you see the answers to their questions. In this case, how much experience do you have with conditions there? How often have you seen it like that? And then these words with underscores in between them are the different pre-named impacts that people have checked off, such as reduced pasture forage, decreased stock weights. That's what that looks like. And then the description or caption information from the free text box looks a little bit easier to read. Severely dry conditions and no rainfall has led to having to heavily supplement pasture, that kind of thing. So main takeaways, there's a landing page where you can find everything related to Seymour reporting, including always the latest updated forms. We are updating them. Part of the reason we wanted to use this Survey 123 technology for a few years, and this will be our 4th year in 2021, is that it's very off the shelf and it lets us configure and reconfigure the surveys. So right now it's in a phase of kind of rapid evolution. What information do people need, and what information are people willing to provide? Before we hard code it, which I think is kind of the modern equivalent of etching something in stone, we wanted to do a lot of experimenting on this lighter platform. So you can sort of check for the current state of the evolution at that landing page. We need consistent observations over time in wet, normal, and dry conditions, not only when it's dry. Photos we're hearing are particularly helpful. And we have kind of a companion tool, the Visual Drought Atlas, where we will eventually be displaying an even broader through time collection of historic photos that people have submitted that just help us have a reference layer. What does a certain landscape look like in dry, wet, and normal conditions? And we'd like for people to add their historic photos to that collection. So these are all things that have come up recently in various conversations as you're recruiting people or asking people to participate or suggesting to them how they can participate. We really are not looking for direct commentary on the US Drought Monitor map. That is in fact immediately suspicious and not received very well. We do want people to describe how the conditions are affecting them. Are they hauling hay, irrigating more? And how does this compare with what's happening at this time of year in a normal year for you? Help us understand how the conditions differ from normal. And any kind of photographic description, or especially sort of a before and after or a dry year, normal year comparison is also very helpful. Photos just say a lot. And ideally, we're looking for people to report at regular intervals. Dry, wet, and normal conditions, consider monthly, maybe weekly during intense weather, dry or wet, or even just seasonally, just to help build a track record so that when we want to evaluate something in a crisis, this place or this person is kind of a known entity. And that's it. Thank you very much.
Thanks, Kelly. That was a great presentation. If anyone has any questions for Kelly about Seymour Drought and how this could be helpful, please use the chat box. Now we're going to transition to our last presentation of the day. Laura is going to talk with us about the Utah Drought Task Force. I think some of you are participating and already know about it, but we want to hear from Laura about how you can be engaged in that effort.
All right, thank you. So I titled my presentation Drought in Utah because I want to hit on a few different points, but then to really focus in on just a couple of those. There are some different parts to drought, and the best way that I could describe them is in various charts, but I want to say that drought, it's a very interconnected web where anything received and learned in one part or talked about is also transferred very easily to the other areas because of the involvement of these three agencies that I have on this slide: the Division of Water Resources, Department of Agriculture and Food, and the Climate Center. Because they participate in all these groups and organizations, the information is able to transfer easily between these different groups. So on these top two branches, there are the focus is the U.S. Drought Monitor maps and making sure that we're contributing. I have down here Utah recommendations and the impact reports, those Seymour reports that were just talked about, and how important those are. And that is a responsibility as a state that we need to, and as residents of the state, that we need to contribute to that, to make sure that that map is accurately reflecting the conditions here, and that that we have an accurate understanding of what is happening right now. The mechanism that we use to make that Utah recommendation is the Utah Drought webinars. And those are on Tuesdays as needed, so not every Tuesday. The next one is on the 15th, December 15th. And I'll mention this many times, but if you want to register for that, it's drought@utah.gov. So very easy, just send an email and say, I'd like to get on the list for the drought webinars, and we'll add you to that invitation list. The bottom two branches there are related to declaring a state of emergency due to drought. And as was mentioned by Brian, that needs to be made by the governor upon recommendation of the Director of Natural Resources. So these drought webinars are held currently every 2 weeks. We want to never have these occurring we want them every month at least. Whether we're in a drought or not in a drought, we have chosen to have that consistency because we don't want a drought to come and then be scrambling to catch up to it. So we're going to hold these every month regardless, but right now they are held every 2 weeks. And you can see on this bottom row of this chart some of the information that's presented. In the corner, there's a sample slide from the last webinar. And they're very interesting, they're informative, they have weather information, and they are open for questions that you can ask anyone who's presented that material, and they can help you with that. The Utah Climate Center presents some material there, and then a lot of federal partners, and we really couldn't do this without those federal partners. They collect a lot of data, weather-related data, and they present that at these webinars, and we appreciate their time to help to that. And then after the presentation of the material, it's maybe 30 minutes, we'll have feedback and observation from anyone on the webinar that day. You can call into these webinars. That's an option if you're not at a place you can connect online. However, we encourage you to connect if you can through computer because of the visual nature of the material that's presented. And the Seymour reports, I will look at those every single week. So someone in the state is looking at those, and they are, as mentioned, you can track through the whole time, we can say, well, the drought really started to get bad in April or in March or whenever. And you can look back and you can have a geographic location for that report. And it's very helpful and it's very important. We're asking a little bit of duplication here to come and listen to these webinars and make an observation. And the reason for that is because if observations are made and people say, in my region, I'm noticing this and I'm located here, then other people in the region can also comment and we can get a more comprehensive understanding of what's going on right then that week. And we can ask questions if we have any comments of, oh, is this a lot worse than you've seen 2 weeks ago? Has it changed a lot in the last week? And we can interact a little bit more than those reports. But the reports are still very, very important to have that history and to be able to go back to them. The observations and feedback that we receive in the webinars, we pass some of that along to the Drought Monitor authors, but some of it, it's in an email, it's not geographically linked, it's not in a database, it's just not recorded the same as those Seymour reports. So I apologize, there is some duplication there that we're asking for, but there's a reason, and I can't think of a way around that, sorry. Quickly, this is just outlined in the state drought response plan, and it is the organization that will determine if we want to recommend to the governor to make a drought declaration or not. And that is a recommendation to the governor. The final decision is up to the governor. This is high-level department heads and people that can make decisions and do funding and different things for their organization. And because of that, they're very active during drought, and then they're a little bit busier when it's not drought. And so we started this other group out of need. It's not an official group, it's not in any drought plan or anything else. It's just a place where we found areas that were missing in the drought webinars. We weren't quite getting comments back about wildfires. We weren't quite getting as many comments back on natural environment and some other areas, tourism, some of that, the effects. And so we started this group to just channel all those effects and gather those into one place about the effect of the drought. And the difference between this and those Seymour reports is the conditions sometimes vary a little bit from the effects. For example, if a reservoir had to be drained to do some work, and then we hit a mild to medium drought, the condition would be mild to medium drought. And that's what we'd want reported, and that's what we'd want in the mapping. But the effect of that may be much greater due to extenuating circumstances that don't really have to do with the drought. Another example might be, if you have to bring in feed because of lack of vegetation, that's a condition that you want to report on the Drought Monitor map. But if feed costs more for some reason because of COVID or something, then that's more of an impact that we want to get through the drought reporting group, is impact-based to make a decision of whether the state should declare a drought or not. The straight drought declaration isn't necessarily linked to the category that we are on a map. And so we want to have that hitting the effects and do it based on need in the state. One thing here about our drought website, we've been working on this quite a bit in the last 6 months, and if we have any statement that we've issued on drought, it'll be on here. This website's just a little bit hard to find. You can go to the Division of Water Resources homepage and then go across that gray bar, and when you get to water data, a pull down will come and it will say drought, and then that will get you to this page right here. You can see barely on the screen on this shot is the map. If you click on that map, you will go to the Utah specific US Drought Monitor web page. And if you scroll down on that page, you'll see the category chart that we talked about earlier, and a link to do a conditions monitoring report. So that's all on there. And that email, drought@utah.gov, to have any questions about drought or to register for the webinars. And then this is also at the bottom, any of the past webinars. You can pull those up and look at those. They aren't recordings, they're just the slides, but you can look at those and see how conditions have changed if you're interested. And again, details on how to register for those webinars and a link to the COCORAS. So thank you. And again, if you want to register for those webinars, drought@utah.gov, or any questions about drought, you can email me, or if you can't remember, email the drought and I will get it. Thanks.
Thank you so much, Laura. That was a great presentation, great information. We are up against time, so we want to hear from everybody on the call one last time. This effort was part of the Drought Learning Network. It's a broad group of climate service providers and natural resource managers. We do have monthly short drought briefings. The next will be December 18th. We'll send you a link to that. I'm going to turn it over to Joel to get the last information back from this group collectively, and then we'll try to keep you on time here. Thanks.
Great, and thank you, Emily. So we've just heard about the information pipeline from local conditions through to the U.S. Drought Monitor and state decision makers. We've heard about available tools that help that information to get from point A to point B, including Twitter, COCORAS, the Seymour Drought tool, and even showing up to these monthly webinars or bi-weekly webinars that Laura just told us about, and sharing your experiences. What we would like to understand on my end and Emily and those of us who are trying to coordinate all of this information is what makes it hard for that information to get where it needs to go. What are the main challenges that you face in reporting drought impacts? And the second question is, what can climate service providers do to make it easier for that information to get where it needs to go? So we were going to do this in breakout groups. We obviously don't have time for that. So what I'd like to ask you to do is to go ahead and type into the chat box your thoughts on the first question. I'm going to ask you to do this twice. So the first question is, what makes it hard for you to report drought impacts? What are the challenges you face to report drought impacts? Go ahead and just type this in and press enter as soon as you're finished. We won't have time to really talk through this, but we'll capture it, and on the back end, we'll sort of look through this. So I think while I'm giving you just a few seconds to type that in, I'm going to remind you what the question is here. I'm going to type this into the chat box. And then after you've answered that question, the next question is, what ideas do you have to help make this information flow easier? Great, I'm starting to see some of these answers come through. Oh, I just sent that to the wrong person. That's okay. So some of you are saying, well, there's a lack of weather data to share. You don't have a way to measure. That's good to know. Finding real-time data to make real-time decisions. Good. So thanks for that. And do you have any ideas that you would share? How do you think it would be? How would you like to share this information? How can this go a little bit better? I'm seeing a lot of really good ideas come through. Utah Climate Center Hub would be great, from Jordan. Thanks, Emily, for typing that in. I'm trying to read some of these as they're coming through. This is good. There needs to be credibility to the drought data. Kevin, that's an interesting one. Could you give a little bit more information about what you mean by that, about credibility to the drought data? If you want to unmute and tell us, you can, or if you just want to type that in, you can do that too.
Sure, I was just listening, and we're encouraged to go out and report drought impacts. My maybe personal, how should I say it? Maybe I really focus on drought because I'm paying attention to it, because it helps me a lot in my job offering suggestions to different producers. Whereas just maybe somebody that's out a weekend recreationer just happens to see a dry stream somewhere and takes a picture of it and says, "Oh, extreme drought in Garfield County," where maybe that stream was diverted for irrigation purposes or is drying up for other reasons than that. And so I guess this consumer collecting drought information and sharing it via tweets or via social media, I'm just wondering how credible is that, and how can we, and the other thing is typically those tweets are something that's dramatic. You know, you don't post anything on social media unless you're going to get a reaction. So just taking all that into context, I'm saying, well, where's the credibility? I'm not saying there's not credibility with SNOTEL and the Climate Center and that type of data. It's the credibility of this locally sourced data that we're collecting.
I think that's a great point. And I think that validity of the data is something that comes up anytime we're collecting crowdsourced observations or citizen science. And it's a problem that needs to be thought of. So thanks for raising that. We are 2 minutes past the hour. Emily, should I pass back to you to close us up? I'm not sure what the protocol here is now.
Sure.
But let me say thanks to all of you who have shared your ideas in the chat box. Really appreciate it. Over to you.
Absolutely. Thanks. Okay, we're going to save this chat. We're going to save all of your comments from the breakout groups. And we just really appreciate you for joining us. We will follow up, since the most asked for thing was another continuation of this conversation. We'll follow up with that. And with that, I will try to keep us on time or close to on time and conclude this webinar. I see that Katie did show her video. Did you want to add anything, Katie?
Yes, just that we got some good responses back on what you would like to see more of, and I'll be reaching out to you to see if you want some smaller group discussion opportunities, or if you'd like to meet in a big group again. But we'll look to continuing this conversation in January.
Thanks, everyone. Enjoy the holiday and really appreciate this. And we will circle back. Bye, everyone.